Hi Linda. I wanted to make this video for you because there have been some slight changes perhaps. Amy and I were talking about some things, and I think we have a really good way of kind of organizing and streamlining everything. And so I wanted to give you an overview. I think it'll help put everything in context, make it easier to understand. There's three issues particularly I want to address. The first is data collection. So the first thing in data collection I want to discuss basically is the type of variables we're going to be collecting. So from the class, we're going to collect 5 categorical and 5 quantitative. The categorical are pretty much what we saw before: gender, their dominant hand. I changed the third question, so instead of looking at their grade level, we'll look at whether or not they're an athlete, because this can be associated with many more interesting things. Also, a lot of times in Math 125, most of the students tend to be freshmen or sophomores, so if we had grade level, it can be potentially very uninteresting. The question about better driver we can change. Basically, we need a categorical variable that has 2 levels, ideally, and it's strongly associated with gender. So we can change that. And finally, favorite movie genre. With a quantitative, this will be collected in class. We'll do the pulse rates both before and after 1 minute of jogging in place. I did it myself. There's a very significant difference. That'll be normally distributed. This will take very little time to do, maybe 3 minutes max. Reaction time. So there's going to be 3 trials from an online game. This will be an example of a positively skewed variable. And the index ratio, which is the ratio where they're going to measure the length of the index finger and the length of the ring. I figured out how to do this. I found out how they do it when they actually do research. They just photocopy the hand. So we can do this very quickly. This will be normally distributed. It should be. And of course, there's a lot of really good interactions. Pulse rate, we can look at both gender and athlete. We can look at the difference in the pulse rate, and then look and see if athletes are different or it's different with respect to gender. Reaction time, again, you have the athlete and gender also. The index ratio, gender is known to be associated with it. Okay. And finally, Amy had a great idea, prep time. This was on a previous survey, and this should be associated with gender. Okay. Now here is something that we haven't discussed, but I think it's very important, which is the fact that we can use this class data in all of the activities we do in class. So in other words, we can show them how to do all the 3 steps with the class collected data. Though obviously I've done data collection, we can show them how to do EDA, then show them how to do inference. We can show them how to do some of the variables in class and then have them to do some of the other variables for activities. And here's the benefits of doing that. First of all, they get to see the purpose of the data collection. They have a sense of continuity. Okay, we're using this data all throughout class, so it's very efficient time-wise. They're familiar with the data, and it's really going to pay off when they get to regression, because they're going to see how we do the regression analysis in class, and they'll have a very clear idea of what's going on, which is going to help the people who are doing the analysis near the end of the class. So that's the idea of data collection. Now the R intro, Amy had a great idea. She said, why don't we make a video for the students and have them watch it before class? And all the video will do, we'll make a video that shows them how to log in, how to get the files, how to put the files in their home directory, and then we'll cover some basics, arithmetic operations, case sensitivity, things like that. The benefits are going to be many. First of all, they're going to come to class prepared, because they're going to have watched the video. It's going to definitely reduce stress because they can do this alone in their own time. They're not rushed, and they can definitely follow a video. We should be able to suppose that everyone in the class can do this. They'll also learn by doing. If they work in a group, we don't know that everyone's actually doing it. And also, it's going to be efficient for us because it's going to help cut out class time. So the confusion factor is going to go down. The efficiency factor is going to go up. Now let's talk about EDA, because this is a question that you had particularly. And so there's really 3 things with the EDA I think are worth mentioning. The first is the main theme. So we want to say exploratory data analysis is a process for doing descriptive statistics. It has 3 steps. No matter what type of data we have, we look at the data, we plot the data, and then we summarize the key features of that plot. We can do the first step with R. Look at the data. We'll have them open the class data set, and guess what? They'll already have done it. That was their take-home exercise, so this will go very fast. And we do a great job in the other PowerPoints talking about how we're looking for missing values, unusual values. We want to emphasize context, of course, what it is that they're looking at, the units, things like that. The next thing we want to do is we want to try to unify things. So, okay, why did we introduce data types? Well, because the way that we do the other 2 steps, i.e. plotting and description, depends upon the data type and the number of variables. And we can show them this nice plot. When we have categorical variables with 1 variable, a box plot; quantitative with 1 variable, histogram or box plot; categorical with 2, we do a side-by-side or group bar plot; with quantitative, we do a scatter plot. And we can also mention that when we have 1 categorical and 1 quantitative, we do a side-by-side box plot. So now they understand why we've introduced data types, because it affects how we do the data exploration. We can do each case now separately by using R and going through each of the 2 steps. So we'll keep hammering home for each variable the 2 steps. For categorical, we can show them how to make the plot in R, and it's easy. It's just a table and then the bar plot command. And then how to describe it, well, there's really only the mode and maybe some basic relations between some of the groups. For categorical, again, show them how to make the plot in R for a grouped bar plot. Again, show them how to describe it. For the 1 quantitative, this is going to be tricky because now we have to introduce the notion of measures of central tendency, measures of dispersion, but then we do R to show them how to do the histogram and how to do the box plot. And for the histogram, each of these have 5 things, right? Histogram has the measure of central tendency, the width, looking at the number of modes, the shape, and the presence of outliers, and of course the box plot has the 5-number summary. And finally we go to 2 quantitative. So we show them how to make a scatter plot in R, and the only thing we have to really use to describe it is the correlation coefficient. The magnitude's the strength, the sign is the direction. And so this will really kind of unify everything. It'll unify the EDA, and it will also unify the fact that they're being shown how to do the 2 steps for each of these cases. So that's kind of the basic idea. And if you have any questions, of course, feel free to ask, but hopefully this kind of gives a good unified picture of what's going on. I can now.